Okay. Minus 5.6. I'm on the warm-ups, by the way, number 2 and 4. Minus 5.6. Okay, now this one's interesting. There's a negative in front of the E, so I'm going to divide both sides by. Nice. Okay, now what's next? Yep, natural log both sides, bring the exponent in front. 6a natural log of E equals natural log of 43.6. Natural log of E cancel because they're inverses. 6a equals natural log of 43.6. Divide by 6. Hey, that problem's not too bad. Natural log 43.6 divided by 6. A equals 0.6. Bless you. Will is allergic to natural logging both sides. Because it's, natural log, that means that it has to have like pollen on it. Oh, Barrett, you found it.
Yeah, I can solve it.
Yes. Where was it? Okay, number 4. First, I look at the operation. Plus is multiply. Natural log 10x minus 14 equals natural log 21. Are you guys okay with me making that 10x minus 14 without showing my work? I distributed. Okay. Now, Guinan circle or cross out? Who said Guinan circle? It's because you didn't look at the other side quite yet. All good, all good. Okay, you guys are killing me again. Making me regret that seating chart every day. Every day you're like, you know what we're gonna do? We're gonna make Mrs. Talbot regret that seating chart. We're gonna wake up in the morning, you're like, day 27 of making Mrs. Talbot regret that seating chart. I don't know, I just made that up. Okay. Add 14. 10x equals 35. X equals 3.5. Okay, however, this is a log problem, which means I need to plug it back in. Log 2 plus log 5 times 3.5 minus 7. Natural log 21. Ha, ha, ha. So satisfying. Okay, any questions about the warm-ups at all? Anything? Excellent. So we have a quiz next week. Just want to say, real quick before we move on. And the quiz review is right here. I want you to look at the first 4 problems on the quiz review. Do you think you got those?
Yeah.
Okay, just checking. It's not bad, right? Yeah. Okay. Alrighty, guys. Now find this. This is yesterday's, we finished up to here, and then 15 is at the bottom of that page. I'm gonna ask you nicely if you could please let me teach for the period of time in which I need to do so. I only have to do 15, 16, and 17, and then you guys can work on your worksheet. And I saw that, I liked it. And then you guys can work on your worksheet the rest of the period. Hopefully you'll finish it. That'll be great. Okay. Number 15 is a problem I know it looks silly, but I want to make sure we understand that it's okay to cross things out on the diagonal. So for A, what I want to make sure is that you can take 9 and 3 and reduce that to 3 and 1. You remember when we did this, when we converted from degrees to radians, we did the same thing. And then 2 and 14 reduces to 1 and 7. So final answer is 3/7. Okay, now B, before I do any of that stuff, I'm going to keep change flip. So keep change flip. Then I'm going to do what I did here with the reducing. So, oh goodness, I didn't. Okay, yeah, so 5 and 25, please stop talking. 3 and 12 is 1 and 4. 5/4. Okay, now keep that in mind. It's okay to cross out on the diagonal. And division is keep change flip. And I could really stop teaching now, but we have examples. Okay, so flip to number 16. You guys can see why we made this a resource page. Exactly. Nobody wants to talk about it. Okay. So for A, the first thing I notice is that I have a 1 on the diagonal. So I'm going to cancel that. But I want to make sure everyone in here knows that you cannot cancel out the X's and the 3's. That is not appropriate. That's not a legal move. Okay, now this particular set of directions also says state any values of the variable that need to be excluded. So I'm going to cover up the numerators and I'm going to say X minus 5 cannot equal 0. X plus 3 cannot equal 0. X cannot equal 5. X cannot equal -3. Okay, then you guys know that those both came from the denominator. Okay. B. B is a division problem. So before I do anything, I'm going to keep change flip. Okay. Two very important things in this problem. First, that you can tell there's a 1 on the diagonal to reduce. Okay, that's the answer for the actual simplifying part of the problem. But the question is, how do I get my excluded values if I keep change flip? And the unfortunate answer is that you have to do it before and after the keep change flip. Yes. Okay. Now in this particular problem, it's not that bad because same one. So I have 9x minus 1 cannot equal 0. That counts for this one, and this one. But I also need this one. Okay, so division problems. You have to check for excluded values before and after the keep change flip. It's being like making sure you're doing a safe job. Okay, and now we've got some like kind of wild stuff. So on C, it's important to me that you know that 2m plus 3 is the same thing as 3 plus 2m. Does everybody know that 2m plus 3 is the same thing as 3 plus 2m? Okay, so that makes a 1. 7 plus 4m over 3m minus 2. Okay, and then I look at the original problem denominators. 3m minus 2 cannot equal 0. 3 plus 2m cannot equal 0. 3m cannot equal 2. M cannot equal 2/3. 2m cannot equal -3. M cannot equal -3/2. Mrs. Talbot, why does it take so much longer to do the excluded values than it does just to simplify the problem? Yeah. I don't know the answer to that, but it's a true statement. Okay, now on D. On D, we're going to be lazy. Now, yesterday I wrote these two out and canceled out one of them, but it's really important to me that you can tell that if I want to cancel out a y plus minus 2, it just cancels out the exponent. Okay, does that make sense? Because you have two of them. So if you cancel one of them out, now there's just one left. And if the exponent wasn't 2, let's say it was 3, would just go down 1 because you canceled one of them out. Do you guys all see that? Unfortunately, this problem is still not very satisfying. So the answer is still y minus 2, y plus 5 over 3y, y plus 2, which I wish it was more simplified than that because, you know, it looks prettier. But anyway, okay, now I have 3y cannot equal 0. Y minus 2 cannot equal 0. Wait, why did I do minus? I mean, I need to do minus, but why did I do it first? Y plus 2 cannot equal 0. Y minus 2 cannot equal 0. Okay, divide by 3 on both sides. Y cannot equal 0. Y cannot equal -2. Y cannot equal +2. How many excluded values can there be? Well, the most I've seen so far is 4 on the problems that we've done. I mean, there's not a limit, but sometimes they have 4. Okay. E, keep change flip. Okay, so let me pause there. First thing I did was keep change flip. Then I combined the stuff on the top and the bottom. I didn't really have to combine the stuff. I could have done the canceling on the diagonal thing, but I think that that's actually harder than combining it into one thing and then reducing. It's up to you. Do you guys want to do expanded form or do you think you can get it without expanded? You can get it without? Excellent. Okay. So remember, it's always there for you if you need it. What does 60 and 30 reduce to? 2 and 1. Great. And x cubed over x squared. Yep. So I'm going to go like this. Does that make sense? Okay. And then y squared and y squared is all 1 itself. So that becomes 2x. That's exciting. Much more satisfying than that last one. Okay. Now, I'm going to say 3y cannot equal 0. 4y squared cannot equal 0. Do you see where I got those from? Okay, then I'm going to go over to after the keep change flip. I already have the 3y. Now I'm going to say 10x squared y cannot equal 0. I'm going to do this in pieces. I'm going to get the same answer repeatedly, though. It's going to be kind of irritating. Divide by 3 on both sides. Y cannot equal 0. Divide by 4 on both sides. Square root both sides. Okay, are you guys okay on the first two? Okay, now this guy, because he has 2 letters, I'm going to break it up into 2. I probably already knew that y could not be 0. I'm really clear on this problem on the fact that y cannot be 0. What about x though? So divide by 10 on both sides. Square root both sides. Okay, last problem of number 16. Keep change flip. Okay, on the denominator of the first one, I did expanded, but you don't have to. This one is really satisfying. But the excluded values are they're it's bad. Okay, anyway, so 5x minus 2's make a 1. 2x minus 3's make a 1. X minus 4's make a 1. Okay, everybody good with that part? Satisfying. Okay, now let's go slow. So this is 2x minus 3 cannot equal 0. Why did I not put the squared? Well, because I just thought about it being broken up into 2. So I'm just looking here and making that not equal to 0, and then that's the same thing. Okay, now I'm here. X minus 4 cannot equal 0. I already have the 2x minus 3. And then after the keep change flip, I already have the 2x minus 3. I already have the 2x minus 3. I already have the x minus 4, but I need the 5x minus 2 cannot equal 0. Yikes. 2x cannot equal 3. X cannot equal 3 over 2. X cannot equal 4. 5x cannot equal 2. X cannot equal 2 fifths. Okay, good news. On 17, we don't have to do the excluded values piece. We just have to simplify, which is great. Yeah. However, there's some there's some there's some box and diamonding. There's a large amount of box and diamonding involved. Okay. Let's start here with A. What can I reduce? Okay. 14 over 35 becomes 2 and 5. Yep. And 20 over 22 becomes 10 over 11. Okay, so that's going to be 20 over 55, which is still reducible by 5. So 4/11ths. Okay. And I'm pretty sure that 22 is not ever going to be 0 and 35 is never going to be 0. So I don't have to worry about excluded values anyway. Wait, did I just answer it in red? The whole thing is ruined. Okay, now B. Keep, change, flip. Do you guys see that these are also, there's some like choose your own adventure here? Like you can reduce different stuff. Okay. So if we reduce, do you want to do, what do you want to do? 6 over 15 or 12 over 15 or 6 over 15? Okay. So that's going to be 3/5, 2/5, 2/5. Okay. And what would 12 over 40 be? 3/10. I did the 2 over 5 over here. Hold on. Switch to black pen. Agreed? Did you guys get 3 over 25? Okay. All right. So there's the process. Now, box and diamond. Okay, here's the thing. I am the laziest person of all time, as you know. I am going to keep, change, flip, and box and diamond at the same time, which means I'm gonna try to just rewrite it factored and flipped. Okay, so start with the easy problem because we're lazy. This one is GCF, which is 5x minus 3. You really wanted it to be 6 and 4. But it wasn't 6 and 4. Did you want it to be 6 and 4 also? In about a hot minute, by the way, I will not be able to diamond and box all of these. Just mean that like I'm gonna do it in my head. I can't show my work all the time when it's just that it's too easy. So I'll probably do it every time there's a leading coefficient on x squared, but if it's something like this, I'll probably just start doing them in my head. You never have to do them in your head. If you can, great. If you can't, fine. Hey, do you notice I did the keep change flip? So that was originally on the top. I've now moved it to the bottom. You're gonna have to keep track of two things at once. You got it. Yeah, you got it. You got to keep organized. Okay, now's the fun part. Cross out. Okay, so x minus 3's make a 1. X plus 4's make a 1. Ooh, this is really good. Nice. I like that one. You can, it just says as simplified as possible, so I just leave it. I would accept either one of those, whatever you want. Okay, last one, deep. This one's times, so we don't have to worry about the keep change flip. GCF of this part is 6. Okay, the bottom factors into x minus 5, x plus 3. This factors into x minus 4, x plus 3. This is 3x squared minus 3x minus 4, which is 3x minus 3, nope, 4x plus 1. Okay. If only that was an America's Got Talent category, but it's not. I looked into it. No, I didn't. I'm kidding. Okay, so it's actually, we had no such thing as a box and diamond in high school. It was all guess and check. So I learned how to do this a different way. I just used my multiplication tables, but I like box and diamond much better. Anyway, x plus 3's make a 1, x minus 4's make a 1, and then the 6 and the 3 reduce to 2 and 1. So I have 2x minus 3 on the top, x minus 5, x plus 1 on the bottom. Okay, now let's just talk about excluded values. We're not going to write them. This is a problem that would have 4 excluded values. If you look at the bottom, so it would be positive 5, negative 3, positive 4, negative 1. Does that make sense? And since it's multiplication, you don't have to worry about the keep, change, flip part of it. Okay. So can you guys find the homework? Aren't you glad we did that over 2 days? Yeah. That would have been a lot for your brain of. Right.
It's just like, it keeps everything check.
You have to, it's like handwriting counts again and gotta go slow and not write too tiny. That's not meant for anyone in particular. I just love you. Just teasing. Okay. Guys, I would like to challenge you to try to finish this worksheet. You have it almost an hour.
Wow.
Um,
It's gonna take a while.
it's okay because if you do finish it, the reward is you have the homework. And then, guys, on Friday in class, you do the quiz review, and then you have no weekend homework. I'm just saying,
We're now, we're like.
if you locked in during the period, you have plenty of time to do it. You could have math-free evenings. I know you have other things you're working on, so